equations of motions. Decoupled, that means for each set of equations, they only contained one independent variable. Okay, so yes. So you see, for each of the decoupled equation of motion that representing in terms of Q1, Q2, etc. Everyone should know how to solve for Q1, Q2, etc. using the old information. Whatever the content of the Q1, the force. For example, if this is the harmonic force, then chapter 3 will be in, right? If the Q1 is the contents of the generalized force, then I will learn in chapter 4. For example, the plot transform, Fourier transform, convolutional integral, whatever the methods we should be able to, in theory, to apply to solve for each of the equations. Is that right? So right now, before we proceed to the numeric calculations, in concept, we should be okay. We should have been prepared for this one. Is that right? Okay. So in this way, keep in mind, bring everything to the final, just for this sake. Okay. So the final will be open notes, open book. Yes. Go ahead.
Yeah, so break that down again. Where Q1 is.
So, for example, we can utilize these simple numeric numbers here. Okay, so this one is Q1, Q2. Right? And this one is Q1 and Q2. Right. So when you break down, this one multiplied with this give us Q1 double dot. This one multiplied with this one give us 2.5 times Q1, and that is this one. In a similar way, if our dimension expanded like that kind of n dimension, the similar process. Because for this is the diagonal matrix. Only element on the diagonal is non-zero. Everything else is zero. So, okay. Any other questions? So, keep everything. Now we can let me copy from. So, for example, if this is the So now I don't need this. So, for example, we look at this particular province here. And if we want to solve for this one, if you remember, let me copy the template from somewhere in the textbook. So the template is this. For example, from chapter 2, and that is a free vibrations. If we have such a problem, x double dot plus omega n squared, x equal to 0, the initial conditions given. Okay, so the solution is this. X0 times cosine omega nt plus V0 divided by omega n sine omega nt. So this is a template, in particular for free vibration, because for this one, the force term is 0, so we know that's a force vibration. So I copied the solution patterns from the textbook. That is a free vibration, right? So with this template, can you say for this particular problem, in this way, we have the solution Q1t will be equal to, say, Q1 0 times cosine omega 1t plus Q1 dot 0 and omega 1 times sine omega 1t. Right? And solutions for Q2 will be equal to Q2 0 cosine omega 2t plus Q2 initial conditions omega 2 sine omega 2t. So here we know the omega 1 equal to this equal to 1.58 and omega 2 equal to this 2.45 radian per second. Right? So plug in what we have learned before, this one solution is there. So with the two things in mind, how to solve for our xt. So therefore, xt, again, this is a linear combination of the model matrix, so it's this one. Xt equal to capital X times Q1, Q2. For our particular problem, let me copy it, 0.2653. So our total solutions two particular freedoms operations problems is this. We have expressed the Q1t, so in this calculation, you plug in such a long writing into here for Q1t, you plug in the Q2 into here, and you implement the final step, then you got a solution xt. You good? Can you, everyone, follow what I'm saying? I try to use plain English. Everything, yeah.
So Qt has a constant in it, right? For one of those, this comes from that blue equation.
Yeah, so
we don't know what that constant is.
Yeah, Qt representing is the blue things, and that is the generic expression. Because here we don't know C1, we don't know Phi1.
So those will simply be based upon the...
that information has been absorbed, encapsulated in Q1. And explicitly, that appear is like this. So if you combine the cosine and sine into the cosine form like this one, then you should be able to find the Phi1. But here we encapsulate all the information into here, and somehow we choose this as the template because I copied the template from here. If you have a different template, identical template, go ahead. Yeah. And in chapter 2, I believe in our one set of the homework equations, we have been exercised. Either I ask you to exercise the equation in terms of this one, in this form, or in this kind of combined composite form, right? If you still remember. So basically, it depends on which form you like. And here, I simply copied this one. But if you like, you can copy this one and then give us what is Phi1. Then we simply copy into that template. Okay? Any questions? So to this step, if you would know Q1, Q2 numbers, and right now we have the numbers here, omega and omega 2, then final solution should be there. This step is very straightforward because that basically is involving the, we realize the solution is in this form in linear combination of the model matrix, basically be written like this. Okay, that's a key step. then plugging into utilize the orthogonality properties, then we are able to decouple into this such simple equations. Good. I can tell you right now, we totally solved this yet. So if I would say, what is these numbers? Give me the full explicit expressions here. What is this? So that basically you simply implement 0.2353 multiplied with Q1 minus 0.169 times Q2. That go to here, right? And what is Q1, Q2? Okay, Q1, Q2 is here. In here, we'll look into more details. In such expressions, and right now you can see how many parameters, we have omega 1 given here. So this one is given, this one is given. Omega 1 is given. What is this? We don't know yet. That is the initial conditions associated with each generalized coordinate system. So we're still lacking one piece, and if we can fill in the last piece, the whole thing will be solved. So that one can be done here. We are given the ICS okay, so that is a given. So look this carefully. And we know for any solution patterns that can be expressed by a linear combinations of the modal vectors, that means we've written in this form. This one is nothing new. And this one basically is what will be written like this line or in this line. Okay, and I want to again manipulate the information based upon the orthogonality properties. I want that properties appear in my calculation in the way I can convert information between X and Q. Okay, so see this one, what I did. I pre-multiply this equation with something, and hopefully orthogonal properties will be appear. So in this way you can see, this is, let me rewrite this one again. And I want to rewrite, so give a little bit more space. So let me pre-multiply M. Okay, so the both sides multiply with the same informations. So in this way, this matrix utilizes the first equation of the orthogonality properties. This one is the identity matrix. Any vectors multiply with identity matrix equal to itself. So therefore, we have the information transformed. So therefore, here let me rewrite. So that information is obtained from here. We take the derivative, the same thing, because those are constant. So therefore, with the two things in mind, then you can see the initial conditions. Q0, and that is Q1 and Qn should be equal to this. Okay, and the same thing for the dot, and the same thing. So for our equations here, the Q transpose and multiply with n. Multiply with x1, 0, x2, 0. We good? So for example here, for our exercise, say, if I was given, say, x1, 0 equal to 1, and x2, 0 equal to 0, and x1 initial velocity equal to 0, x2 initial velocity equal to 0. So with this given information, you should be able to calculate for q1, q2. So that means this number is calculated, that number is calculated. And in the similar patterns, the initial velocity, take the same template, and let me use the saved time. So that means with the same template, and you plug in that information, the two pieces are given there. So basically, this information is given, and this information is given. So by this moment, we are able to numerically completely solve for this one, and that should be coming to here. Okay, so I have the older things. I will try to scan, and that's a whole set of equations from the beginning. So I will scan and then email to everyone. And doing my calculation, again, I found a mistake in my notes, but not for today, but for Friday's lecture note. I'm going to revise it, give me a few hours. So from this moment, hopefully you can stick with this simple example and then rehearse the whole thing. Also in homework 13, the part 1 on the homework 13, I put at least one very thorough, detailed, calculated example. You can follow up that one as well. And also in part 1 of homework 13, I propose another 2 examples that is from our textbook. So encourage you today and go back to right away to go over those examples. Again, those processes are very prone to making calculation mistakes. And my experience is if you are capable and put it into MATLAB coding, okay? But for final exam, because here I won't allow to access computers, so only in a few days polish your hand calculation. Fine. A lot of the calculation basically is something like this, multiplication of the matrix with a vector. So if you have any TI calculators, implement some kind of simple code in that calculation and help you to quick punch. Are we okay? Okay, good. Okay. Yeah, so Friday we will continue to exercise